Get ready, because Elon Musk has just dropped 7 words that could shake the aviation industry to its core. I'd actually love to make airplanes especially simple, direct, but packed with revolutionary intent. And Musk, as always, didn't leave it there. He followed up with a revelation that he's been sketching, calculating, and envisioning aircraft designs for years, waiting for the right technology to catch up with his ideas. What he finally revealed was stunning: a fully electric, supersonic, vertical takeoff and landing jet. And now that vision isn't a sketch anymore. It has landed in reality as Tesla's super electric plane, priced at an eye-catching $79. The announcement is sending shockwaves worldwide. After decades of red tape, regulatory fights, and relentless pushback, Tesla has managed to break through. Even legal barriers that had once seemed immovable, many of which were only dismantled in the Trump administration, are now history. The path for electric aviation is open, and the hunger from the public is ferocious. Everyone wants clean, silent, affordable flight. Yet one enormous question has always loomed: how could anyone possibly solve the crippling weight issue that has haunted electric aviation for decades? How could a plane carry such massive batteries and still be safe enough to satisfy the Federal Aviation Administration's unforgiving safety regulations, all while remaining affordable to the average professional or business owner? In the next stretch, you're going to hear exactly how Tesla pulled off this miracle. By the end, you'll understand how they made the impossible possible. If you're stunned already, make sure you subscribe and tap the bell, because this is just the beginning of Tesla's flight revolution, and you don't want to miss what's coming. So let's start where it matters most: price. Because somehow Musk and his team at Tesla have pulled off the financial miracle of the century. Imagine buying a futuristic supersonic electric aircraft for less than your neighbor's tricked-out SUV. That's right, Tesla's plane isn't just a piece of luxury. At $79,597, it's cheaper than a fully loaded Ford F-150 or luxury family sedan. And yet what you're getting is an aircraft that could put coast-to-coast travel right in your hands. How did Tesla do it? The secret lies in their production pipeline. They've taken the same formula that revolutionized car manufacturing and scaled it up for aviation. Their Nevada Giga Air plant is an engineering marvel in itself. Think of it as Gigafactory 2.0. This single facility is projected to churn out 12,000 electric planes a year by The key is Tesla's GigaPress technology, the very same innovation that slashed Model 2 costs and made mass EV affordability possible. These presses can stamp out entire fuselages in one seamless piece. The result: assembly time cut by 65%, and overall production cost reduced by a staggering 55%. And there's more, because this is happening right in the heart of the United States. The plant is more than a factory. It's an economic engine. It's injecting 10,000 new jobs into Nevada and funneling $1.2 billion annually into the U.S. economy. That's not just engineering efficiency, that's patriotism and economic growth working hand in hand. Every plane rolling out of this plant saves an estimated $25,000 in production costs alone, simply because Tesla dared to rethink how aviation should be built. Of course, production is only half the battle. The true game changer here is the battery. For decades, electric flight was dismissed as impossible because of battery costs and weight. But Tesla cracked the code with its revolutionary aluminum-ion battery technology, developed at their cutting-edge Gigafont lab. These batteries cost only $45 per kilowatt-hour to produce. To put that into perspective, the industry average still hovers around 110. That's a 60% drop. Multiply that across a 100 kWh pack, and Tesla is saving $6,500 per plane instantly. But it's not just about price. Performance is just as jaw-dropping. These aluminum-ion packs deliver a range of 1,300 miles. That covers 97% of U.S. domestic flights, from Los Angeles to New York on a single charge, and all of it at a fraction of the cost of what competitors are attempting. Tesla has even closed the loop on sustainability. At its Texas recycling facility, they reclaim 85% of battery materials, reducing raw lithium demand and cutting costs by another 3%. This kind of vertical integration has competitors scrambling to even keep up. And for those who can't quite justify owning their own aircraft, Tesla has reinvented accessibility with their SkyShare model. Instead of paying outright, individuals or businesses can opt into a shared ownership program at just $4,500 a month. This works like Airbnb for aviation. Flight schools, entrepreneurs and adventure seekers can pool resources, sharing not just ownership, but also maintenance and charging. Analysts estimate this system could capture nearly a quarter of the U.S. electric V2L market by 2030, lowering the barrier to entry for a whole new class of pilots. Meanwhile, Tesla's Dojo supercomputer, the same one that has already revolutionized their self-driving cars, is now running the show in aviation. Dojo's AI analyzes every stage of plane production, trimming waste by 75% and saving $18,000 per plane. Looking forward, by 2026, it will even forecast global demand and secure raw materials in advance, locking in rock-bottom prices that cut another 12% from production costs. When you add up all these pieces, Tesla isn't just introducing an affordable aircraft, they're setting the stage to dominate 30% of America's small aircraft market by 20. But if affordability is half the revolution, weight and structure are the other half. The problem with electric planes has always been obvious: heavy batteries. Traditional lithium-ion packs are so dense and cumbersome that planes carrying them were barely functional. And unlike fuel-powered aircraft, which burn fuel and lighten their load during flight, electric planes are stuck lugging the same dead weight from takeoff to landing. Tesla's solution is nothing short of breathtaking. Enter the Starvolt aluminum-ion battery. With an energy density of 0.18 kilowatt-hours per pound, Starvolt is 60% more efficient than lithium-ion competitors, which typically manage just 0.111. What does that mean in practice? A pack powerful enough to fly 1,300 miles weighs only 1. A lithium-ion version of the same range would weigh nearly 4,000 pounds. That's 2 tons of extra weight Tesla just eliminated. This breakthrough alone transforms electric aviation from fantasy to reality. But Tesla didn't stop there. Partnering with SpaceX engineers in Nevada, they designed a carbon fiber frame that is 25% lighter than standard aluminum airframes. That alone trims another 60 pounds. Then, inspired by the Cybertruck's exoskeleton, they developed a chassis that spreads weight evenly across the aircraft. This reduces landing gear strain by 30%, or roughly 1,200 pounds of pressure. Add in compact Starvolt-powered V2L motors that shave 330 pounds more, and the weight savings start to look revolutionary. Even the act of landing has been reimagined. Starvolt's fast charge, fast discharge chemistry allows the plane to recapture 18% of its energy during descent, effectively shedding 20 pounds of equivalent battery load every landing. And thanks to Starvolt's thermal stability, Tesla no longer needs bulky cooling systems, saving yet another 65 pounds. With smart AI-driven aerodynamics adjusting wing flaps in real time, the plane reduces strain by 20% under heavy battery load. To handle the stress of landings, Tesla tapped SpaceX's expertise again, building landing gear from titanium alloys, capable of withstanding 6 times the plane's weight. With all this combined, Tesla has achieved something no one thought possible: a lightweight electric plane with long-range fast charging and robust structure. It's American engineering magic. But solving weight wasn't enough. The FAA's safety standards are notoriously strict, and for good reason. Planes cannot afford failure. Tesla approached this challenge with the same obsession for safety that it applies to its cars. Starvolt batteries were put through brutal tests. Temperature swings from 58 to 76, vibrations at 12 times the force of gravity, and came through unscathed. They are 99.8% non-flammable, virtually eliminating fire risk. This feature alone stunned FAA officials. Tesla invested $15 billion into U.S. testing facilities, creating 5,000 jobs to make sure their planes don't just meet, but exceed regulations. Certification under FAA Part 23 is already targeted for late 2020. Beyond the batteries, safety redundancy is everywhere. The plane features dual battery packs, quadruple redundant controls, and AI systems trained on 10 billion miles of Tesla's driving data. Even if 2 systems fail mid-flight, The aircraft can glide to safety. The cockpit is armored with ultra-strong Tesla glass, able to withstand 5 times the plane's weight. The battery packs themselves are wrapped in Kevlar shells, capable of absorbing 50% more impact than conventional enclosure. Every inch of this aircraft is designed with worst-case scenarios in mind. And what about real-world operations? Tesla's engineers thought of that too. At 30,000 feet, passengers rely on oxygen systems and cabin pressurization. Tesla's Starvolt batteries power compressors that keep cabin pressure 10% higher than most commercial jets, reducing fatigue and making flights more comfortable. Triple redundant oxygen generators provide 40 minutes of emergency supply, more than double the FAA requirement. The plane also integrates seamlessly with Starlink satellites, giving pilots real-time weather, navigation, and communication data. This cuts delays by 25% compared to legacy systems. And when it's time to recharge, Tesla has adapted its semi-truck mega charger network to Aviation. The Starvolt pack can recharge to 80% in just 30 minutes. That means 4 to 5 flights a day, turning what might have been a novelty into a serious commercial workhorse. And perhaps the most exciting detail of all, vertical takeoff and landing. The Starvolt system gives the plane the ability to land on city helipads, cutting travel time by 60% and bypassing crowded airports entirely. Imagine flying coast to coast with better Wi-Fi than your cable provider, charging in half an hour, and landing in the middle of a city instead of fighting airport traffic. That's not sci-fi. That's Tesla's plan. When you add it all up, the affordability, the weight breakthroughs, the unmatched safety, the real-world practicality, you realize Tesla hasn't just built a plane. They've rewritten the rulebook on aviation. The $79,597 super electric plane is more than a product. It's the dawn of a new era, where electric aircraft could become as common as electric cars. So ask yourself, what would you do if you could own the skies for the price of a car? Would you fly cross-country at a fraction of today's cost? Would you join a SkyShare program with friends or colleagues? Would you finally chase the dream of piloting your own aircraft? Because Tesla isn't asking if the world is ready. They're showing us it's already here. This is American ingenuity, boldness, and vision, on full display. Built by American workers, powered by American technology, certified under American standards, and ready to disrupt the skies like Tesla once disrupted the roads. If this blew your mind, type the words Starvolt or Tesla did it in the comments to show you're part of the future of flight. And don't just watch history unfold, be part of it. Subscribe, turn on notifications, and stay with us as Tesla's aviation revolution takes flight, because the next chapter of transportation is already in the air, and it's landing sooner than anyone ever imagined.